All right, this time we're going to do reaction 2, which is the reaction of magnesium metal with the hydrochloric acid. And we're going to do a little calorimetry to try to figure out delta H for this reaction. So once again, I measured out 100 milliliters of the HCl. We're going to assume that's 100 grams. The initial temperature was the same as
100 grams of HCl.
100 grams of HCl. Again, most of this is water. There's going to be a little bit of air in there, but I think it's going to be pretty close to 100 grams of water. The initial temperature is still going to be 23.1 degrees Celsius. Now this is a little piece of magnesium. I have to tear it first. I told you to take about a 10 centimeter. 10 centimeters is about the size across your hand. That's how I always measure it. And it looks like its mass is 0.26. So 0.26 grams of magnesium.
I don't think the computer is getting that. There we go. There's some kind of glare on it. There. So now they can see 0.26.
So 0.26 grams. So we're going to stick this into our calorimeter with our hydrochloric acid. And I will say that normally I would probably have a little lid on the calorimeter just to keep the heat in a little bit better. But I think for the purpose of seeing it, we're just going to leave that off. So it fizzes. It's a pretty good reaction. It's producing hydrogen gas. And it's definitely exothermic. I can see the temperature is up to, stir it a little bit.
You can hear it.
You can hear it. It's up to about 28 degrees right now. Now you may have done this reaction in class. We do this for a number of things, and you've probably noticed that in the test tube it does get quite a bit warmer. So right now we're at about 32. I'm going to keep stirring it a little bit. Now this is not a perfect calorimeter. There is some heat being lost, but for our purposes I think it's going to be pretty good. Looks like most of that magnesium is gone. So I'm just going to check the temperature and see if it climbs anymore. Right now we are at about 34. And I think I'm going to stop there and read that as 33.8 degrees Celsius.
Hydrogen gas tickled my nose, Mr. Habel.
I know it does. You don't want to breathe too much of that. So I've got, once again, my data is my mass of my HCl is 100 grams, 100.0 grams. The mass of the magnesium was 0.26 grams. The initial temperature of the HCl, which we're going to treat as water, we're going to treat that as having the same specific heat of water. The initial temperature was 23.1 degrees, and the final temperature was 33.8 degrees.
33.8, write that down, don't forget.
33.8, nerds, that's what your teacher calls you. And your job, again, is to figure out delta H for this reaction. And I'll just say, I tell my students there's kind of 3 steps. The first step is to figure out how much heat was gained by the water in the cup. That's with your specific heat equation. Then I say how much heat was gained by the reaction, and I put that in quotes because the reaction's losing heat, it's exothermic. But it's the same number, opposite sign. Delta H then is that you take that number of joules and divide it by how many moles of the reactant, which is the magnesium. So delta H is going to be the heat per mole of magnesium. That'll give you delta H. Watch your sig figs, right? This number here was 2 sig figs, 0.26 grams. So none of your measurements after that can have more than 2 sig figs.
Do you love sig figs like we do?
I do. I love that sig figs. And I also love units. So every number you use in any of your calculations should also have a unit attached.
Right.
All right. Have fun.
Thank you.